Hello, and welcome to a new video for our course Finance 1. Today we're going to continue talking about options. And we're going to move into something that we haven't done before. We're going to try to say something about what the prices of these objects should be, what the price of a call should be, and what the price of a put should be. Now, in general, doing this is beyond the scope of this course. But we're going to be talking about specific situations in which we will be able to say something about what the price of a call or a put could be, or at least what are the ranges in which the price of a call and a put should be. So we'll start talking about one thing that is known as the put-call parity. And in this case, we can actually find the price of a call given the price of other financial assets. We can also find the price of a put given the price of other financial assets. And then we're going to talk about intervals in which the price of a call or a put should be. We'll be talking about minimum prices that they should have and also maximum prices that they should have. Let's go at it. Let's start with the put-call parity. Now, this is an equality that we're going to derive, and the way we're going to derive it is that we're going to be presenting two different strategies. In one, we're going to be doing two investments. We're going to be buying, two financial assets, and the other one, we're going to do the same. They're going to be different, but it will turn out that their payoffs are going to be, the total payoff of these two strategies is going to be identical. And therefore, we will invoke the law of one price to conclude that their price should be equal. So let's start with the first strategy. Now, this first strategy involves the following purchases. We'll purchase first one stock, and then we will purchase a put option on this stock with a strike price, for example, of 100, just to make the example more specific. Now, if we do this, what would be the resulting payoff of this strategy? Let's divide it into cases. The resulting payoff, when considering cases in which the price of the underlying, the price of the stock at maturity is below the strike of the option, in this case 100, and the payoff when the price of the stock at maturity is actually higher than the strike price 100. So for the put, as you know, a put gives you the right to sell at a given price, not the obligation. Then the payoff at maturity, if the stock, the price of the stock is lower than 100 at that point, and since we will exercise that right because we can sell at a higher price than if we go to the market, then the payoff would be 100 minus whatever the price of the stock at maturity is. However, if the stock is higher than the strike price, we know that we won't exercise that right, and then our payoff is going to be 0. Now, what's the payoff of the stock? Well, the payoff of the stock at maturity will just be the price of the stock at maturity. Remember that we're looking at payoffs. We're not looking at profits of the strategy, just payoffs. Total payoff of this strategy then is just the sum of the payoffs of these individual components. So if the stock is below 100 at maturity, the total payoff will be 100, no matter what happens, as long as it is below 100. And if the price of the stock at maturity is above 100, the payoff will just be the price of the stock at maturity. We can just plot this in a graph. So if the price of the stock at maturity is in the horizontal axis and the corresponding payoff of the payoff we plotted in the vertical axis as we have been doing so far, then we know that the payoff of the put will look like that. the payoff of the stock, which will just be the price of the stock at maturity, will look like that. And then we have just derived that the payoff of this total of the complete strategy will be that one. By the way, this strategy is also known as a protective put, as you have already seen. Now let's go into strategy 2. Suppose that we consider alternatively the following purchase. We put money in the bank, say 100 monetary units. No, sorry. Suppose that we put in the bank enough money so that when we go back and get it back, the amount of money that we have earned is equal to 100 monetary units. So we're actually putting in the bank the present value of 100 monetary units at maturity. And in addition, suppose that we buy a call option on the stock, the same stock that we had in strategy 1. And exactly same strike as before, and of course same maturity as before, as for the case of the put option. Let's go ahead and try and derive what the payoffs of this strategy will be. And let's start with the payoff of the call option in those two different cases as before. So the call option, remember that the call option is a financial asset that gives you the right to buy the underlying, the stock, but not the obligation. Now, in this case, obviously, if the price of the stock at maturity is below 100, we will not exercise that right because we can buy it cheaper in the market. So the payoff of the call will be 0. However, if the price of the stock at maturity turns out to be higher than 100, our payoff will be the difference between the price of the stock at that point and the strike price that we have assumed, that is 100. Now, what would be the payoff of that deposit that we have put in the bank? Well, since our deposit was for an amount equal to the present value of 100, at maturity, our payoff will be nothing but 100. Now, what will be the total of this total payoff of this strategy? That is, what will be the payoff of this strategy? That is the total of the payoff of its components. Well, if the stock is below at maturity, if the price of the stock is below 100, then no matter what happens, the payoff will be 100 as long as it is below 100. However, if the price of the stock happens to be above 100 at maturity, then the payoff will be just the price of the stock at that point. And you probably guess now that the payoff of these two strategies, strategy 1 and strategy 2, is going to be the same. Let's see what the strategy with the payoff of strategy 2 is. Well, on one hand, we have the payoff of the call that we have just derived, and then we have the payoff of the deposit in the bank. Now, we also concluded that the total payoff of the payoff of this strategy, which is the total of the payoff and individual components of it, is going to be equal to that. So when we compare it with the payoff of strategy 1, we see that is identical. So, what is then the put-call parity in our example? Now, since the payoffs are identical, no matter which one of the two strategies we choose, the long one price tells us that the price of the strategy 1 and the price of the strategy 2 should be equal. Now, strategy 1 contains the purchase of a put and a stock. And strategy 2 contains the purchase of a deposit, the purchase of a call, and a deposit in the bank for the present value of 100. What is the price of a strategy 1 then? Well, that price is the price of the put plus the price of the stock, P plus S. And what is the price of a strategy 2? Well, the price of a strategy 2, which contains a deposit in the bank for the present value 100, is nothing but the present value 100 plus the other purchase that it contains, which is the call, plus the price of the call. Now, they need to be equal. And this is just what the put-call parity says in our example. And recall that the strike of both the put and the call are equal. Now, of course, this reasoning applies to any strike price that we can think of. So as long as the strike price of the put and the call are identical, and the deposit in the bank is for the present value of the strike price of the two options, then we can derive this equality in general. And that is known as the put-call parity. So, the important point of this tool, of this equality, is, well, in reality should be verified, because otherwise we'd be able to find an arbitrage opportunity. And second, if we know the price, for example, of the put, and the price, of course, of the underlying at a given point in time, then we know that what the price of a call with the same underlying and maturity and strike should be. And vice versa. If we know the price of the call and the price of the stock, and well, and the interest rate, of course, then we can figure out the price of the put, which has the same maturity, same underlying, and same strike price. Now, this is a situation in which we managed to actually find the exact price of a call or a put option given the price of other financial assets. Now, there is something that in general we can say about what the price of a call and the price of a put should be. And we go at that. Now, we can create intervals in which the price of a call and the price of a put should be. And we are going to start doing this by using a starting point, the put-call parity itself. So let's talk about first minimum prices for the put option. And again, as I said, as I anticipated, let's recover the put-call parity. So this is the put-call parity. And suppose that we move the stock to the right-hand side of the equation, and then note that since the price of a call always has to be greater or equal than 0, the call gives us a positive payoff, a payoff greater or equal than 0, and therefore it should have a price greater or equal than 0, then if we remove the C from the right-hand side of that equation, then the equality turns into an inequality. And thus, from this we learn that the put price can never be lower than the present value of its strike price minus the current price of its underlying. The stock in this, the stock or whatever the underlying is. That gives us a minimum value for a put option. Let's see what a minimum value for a call option should be. Oh, sorry. Let's just illustrate this with a graph. Now, there's the deposit, the payoff of the deposit, which is just 100. There's the short position on the stock, the right-hand side of that inequality. And the combined payoff, the total payoff, is going to be given by that. That would be the deposit plus the short position on the stock. Now, where does the payoff of the put lie? Well, payoff of the put is right there. And note that the payoff of the put will always be greater or equal than the payoff of the combined strategy that includes a deposit plus the short position on the stock. Hence, the price of the put will be larger, greater or equal than that combined position. This is just the illustration that we managed to derive via an equation just before. And there it is. Now, the reason that we're going to be using to derive what the lower price of a call is exactly identical. We're going to be recovering once again the put-call parity. Let's express it now in this way. That is, we move to the right-hand side what we had in the left-hand side. It doesn't matter. And let's just move to the right hand the present value of the strike. Now, we're going to do exactly what we did before. Let's remove from that equality, noting that the price of the put has to be greater than zero, the put price. Then that equality turns into an equality, which means that the call of the price can never be lower than the current price of this underlying, the stock in this case, minus the present value of this strike. Now, we can actually illustrate this inequality with a graph to be able to understand the intuition behind this inequality. Now, look at the inequality. And on the right-hand side of the inequality, we see that what we have is the price of the following strategy. On one hand, we are putting the present value of the strike price in a bank. And on the other hand, we are shorting the stock. Now, what the inequality tells me is that the price of the put should be greater or equal than the price of this strategy that I just described. And let's see why this is in a graph. So, if we once again plot the payoff of each one of payoffs, if we once again plot the final price of the stock in the horizontal axis and payoffs in the vertical axis, let's start with the components of the right-hand side of that inequality. Now, one of them was the deposit. Since we're putting in the bank the present value 100, we're just going to get the present value, the 100 at maturity. Again, just to make the plot, I'm assuming that the strike price is 100. Of course, it can be anything. Now, the other part of that strategy was the short position on the stock. We're selling the stock. The combined payoff of this two actions is going to be that. That will be the payoff of the strategy whose price we find on the right-hand side of the inequality. Now, on the left-hand side of the inequality, we have simply the price of a call. What's the payoff of a call? Sorry, of a put. What's the payoff of a put? That's the payoff of a put. And then what we observe is that the payoff of the put is always greater or equal to the payoff of the strategy whose price we found on the right-hand side of the inequality. Hence, since the payoff of the put is greater than the payoff of the strategy, then the price of the put has to be greater than the price of the deposit plus the short position on the stock. Hence, the inequality that we have just derived. Now, we can do exactly the same with the price of a call option, following identical logic. Let's recover the put-call parity. This is the put-call parity. The only thing we have done is that we changed the size of the equality, but it's the same thing. So now suppose that we start again with the put-call parity, but now we move the present value of the strike to the right-hand side of the equality. And now, suppose that we remove the put price from the equality, noting that this price is going to be greater or equal than 0. Now, if we do that, the equality turns into an inequality, of course. And that's it. We know then that the call price can never be lower than the current price of his underlying minus the present value of his strike price. Now, we can also illustrate in a graph this inequality. And to do so, note that on the right-hand side of this inequality, you have the stock price and minus the present value of the strike price. This is actually associated with the following strategy. You buy the stock, and at the same time, you borrow an amount of money equal to the present value of the strike of the option at maturity. The strike price of the option. So, if we go ahead and we plot the payoff of such a strategy, we have on one hand that we're buying the stock. Let's start with a loan. We're borrowing the present value of the strike price of the option. So the payoff is that we need to return the loan. If it was the present value of the strike price of the option, suppose that strike price is 100, just to make this illustration more specific, then we need to return that loan, and that would be for 100. So at maturity, we need to pay 100, no matter what the value of the price of the stock at maturity is. Together with that, we said, okay, we bought the stock price. And the payoff of having done that is exactly that. The combined payoff of these two actions is that one. Now, what is the payoff of the call? We know that the payoff of the call with the strike price 100 is just that. And it happens to be always greater or equal than the payoff of the strategy associated with the right-hand side of the inequality. Hence, the price of the call must be greater or equal than the price of the strategy. Hence the inequality. Now, let's move into finding maximum values for the price of a put and the price of a call. And let's start with the put. We're going to do this directly into the graph. Now, suppose that we once again make a deposit in the bank for the present value of 100 monetary units, and then we, at maturity, our payoff will just be 100 monetary units. And suppose that we compare this payoff with the payoff of a put option whose strike price is 100. What we immediately notice from this graph is that the payoff of the deposit will always be greater than the payoff of the put option. Hence, the payoff of the deposit, hence the price of the deposit should always be greater than the price of the put option. What does this mean? The price of the put can never be greater than the present value of the strike price of the put. Now, what about the maximum value for the price of the call? We're going to do it also directly in the graph. Suppose that we look at the price of the stock. Suppose that we look at the payoff of a stock. So if we buy a stock today, we know that at the maturity of an option, the payoff will be that. Now, the payoff of a call option, whose underlying is this stock, and say its strike price is 100, is going to be that one. So no matter what the price of the stock at maturity is, the payoff will always be greater than the payoff of the call option. Hence, we have that inequality. And note that this inequality in this particular case involves an option that doesn't matter what its strike is. So this inequality applies to any call option, regardless of what the strike is. No matter what that strike is, we know that the price of the stock will always be greater than the price of the call. So this was it for today. Thank you.